I just want to explain an important article in 2023, which is called Reveal the Unknown Out of Knowledge-Based Mention Discovery with Entity Linking. The idea is that discovering entity mentions that are out of knowledge base from text plays a critical role in knowledge base maintenance, but has not yet been fully explored. The current methods are mostly limited to the simple threshold-based approach and feature-based classification, and the datasets for evaluation are relatively rare. So they propose blink out a new BERT-based entity linking method which can identify mentions that do not have corresponding knowledge base entities by matching them to a special nil entity. Because those that are not in the knowledge base, we put in a special token, which is nil entity, special entity, which is called nil. So to better utilize BERT, they propose a new technique, including nil entity representation and classification with synonym enhancement, and they apply knowledge-based pruning and versioning strategies to automatically construct out of knowledge base datasets from common in knowledge base datasets. So given a knowledge base containing a set of entities and a text corpus which a set of mentions are identified in advance, entity linking, entity disambiguation, or entity normalization is to map each mention in M to its corresponding entity. Due to limited knowledge coverage of the knowledge base, it is possible that there is no entity in E that can be matched with a given mention. And so given a text with a set of identified mentions, the out-of-knowledge base discovery is to develop a function such that each mention is mapped to some entities, and some of them are mapped, of course, to the nil, which is a special entity when we couldn't find it. And for candidate creation, we use ByEncoder, and the ByEncoder fine-tunes two BERT models: BERT for mention, BERT for entity, to embed mentions and entities respectively into a dense embedding space, so that given a new mention, the nearest candidate can be easily retrieved. For a mention DM and entity DE, their embedding can be accessed like these two. So red is just, we'll reduce it to like some kind of pooling mechanism, and the mentions and entities can be fed into BERT models in different ways. So the ByEncoder can be trained with a loss function to make each mention close to its matched entity. So here, this alpha is just a margin of small value. We typically put 0.2 for that. And this one is just the maximum of that value on 0. So we know that for each mention to its goal entity in a batch, we can have this loss for mention I and entity I. And then we have candidate re-ranking, which that you have seen in previous lectures, that first we do retrieval and then we go re-ranking, because we have millions of entities, so we should reduce the number of them. And after that we go to the re-ranking process, that we just rank because we have selected top K candidates, and so it's so easier to deal with in machine learning paradigm. So the vector constitutes the parameters to be learned for this entity and mentions. And finally, because E denotes the indices of the top K candidates, we have got the top K candidate entities of M, and I is the index of gold entities, and so the cross loss is like this. So first we do embedding for the mention as well as the entities in the knowledge mass, because for example in knowledge base we also have access to synonyms. For example, if you use UMLS knowledge base in biomedical text, you also have access to the synonyms, and that's why you can embed both of them in the embedding space, which have entities and synonyms. And then we get the top K entity candidates, which if we include with the synonym and then putting cross encoder, you can get, after doing softmax, you can get that it's a range from 0 to 1, and then we get the loss, and we do back propagation to tune the variables. The blink out does not consider the nil entity, but in this paper they consider it. They present nil entity for representation and classification, and then they just use joint training for nil classification, because the binary cross entropy loss is just so this one is for nil when you have a nil entity, and we combine this because there is a factor. This is hyperparameter that we can use to see how much we care about this nil entity. The nil entity does not have a native textual representation in the knowledge base, and the original blink focuses on the Wikipedia text and does not consider synonyms. And then we do synonym concatenation in cross encoder. It is inefficient and infeasible to use synonym augmentation in the cross encoder, as a number of classes can be significantly increased. For dataset construction, they use some kind of knowledge-based pruning. They randomly sample a portion of the entities in the target knowledge base and remove them from the knowledge base. And for evaluation, they use these metrics, precision and recall, everything standard.